This course teaches you about operating system security. The operating system is the system underlying the applications you run. It can be Windows, Linux, Android, or whatever system. You will learn about different threats on your system, like malicious software and others. You will also learn how operating systems can be hacked and different techniques that can happen for Linux and for Windows. This is a beginner's course, you don't need any prior knowledge, and it's really focused on cybersecurity. And so if you want to learn more about cybersecurity and operating system security, this course is for you. Every day you use a smartphone, a laptop, or some other type of computer. This computer always interacts with an operating system. So these operating systems can be iOS, Android, Windows, or any other system. So what is an actual operating system? So to see an operating system, we divide the system into different layers. So obviously you use programs every day. When you use iPhone, your Android phone, or your Windows computer, Mac computer, different programs like Firefox, Chrome, Office, World of Warcraft, or any other program, like the apps you can install on your device. So that is software. It doesn't actually exist in the physical world, it's software, and this is things you can install easily. Another thing is the hardware, so that should be very familiar, like your monitor, your keyboard, your mouse, your disk. So inside the computer you have the physical parts, and that is hardware. So in this case we have a desktop computer, and inside there is the electronics board, or if you have a phone, the whole thing is hardware, including the electronic that inside. And so that is the hardware, so different hardware components. Also these components you can usually replace, like you can install a different keyboard or a different mouse, even a different monitor. Now on a physical phone that's a bit harder, but that's when we talk about hardware, that is the physical components. And software, usually we talk about programs running on top of the operating system, so like Chrome, Firefox and all that. Now there's also the operating system. Now you might be familiar that you can buy different phones, like an Android phone and an Apple phone, and some apps may work on the Android phone but not on the Apple phone, and vice versa. So the operating system is the layer in between the hardware and the programs layer, and there's many different operating systems. And so for example there's the Android system, the iPhone system, and many others. So it sits in between, and it's always there in the background. So it communicates between the programs and the hardware. That is basically the role of the operating system. So the operating system is not hardware, it is a software that you can install usually onto your device. Now there's been many different operating systems. They change over the year in terms of popularity. For example, in the past, Windows was the most popular system, so that is the time before smartphones and tablets and all that, and Windows was the most commonly used, and then the OS X system. So we're talking about 2009. Now if we're looking at present, then you can see that Android is actually the most used system, and then Windows and the MacBook. So now Android is the most popular system. So you see that it can change over time in terms of what is the most popular operating system. So operating systems can be designed for specific systems. For example, Android and iOS are really for the phones and for tablets, whereas Windows, OS X, and even Linux and some others are just made for the traditional workstation computer. And it would be really weird to have Android on your workstation computer or Windows on your phone. So operating system can be specifically designed for the device. So operating system can be very important because if your operating system is compromised, it means that they can access all your apps data, all your programs data, all your private photos, might access your email, the passwords saved in your browser, your banking apps, and a lot of confidential and private data. So the operating system is very important because so much of its security depends on it, of all your apps, because it is the layer in between, right? So it is the layer in between that can access all your apps data. That's why you want to be very careful with your operating system security. Now you have a lot of choices with operating system. So here is just a small list. But there's many more operating systems. So there's all the different versions of Windows systems. These are actually different operating systems. So when you have a different version of a system, it's actually a different system, right? So Windows 98 is a different system than Windows 2000, for example, or XP. Even though some of the components are the same and work the same, we speak about different systems. So obviously we have Windows, there's the different Mac systems, Linux, there's FreeBSD, different Linux flavors, Android, iOS, there's Symbian, BlackBerry, and there's even KaiOS, like other mobile phones, like a bit more niche systems. So there's all kind of different systems, and your whole device security depends on the operating system. So obviously when you install an old version of an operating system like Windows 95 or Windows 2000, your data is not secure, your personal files, your email files, your passwords and all that. So you want to be up to date with your system, whichever system you use. And most systems allow you to install updates. So on the workstation, that's often done by default. On Windows and Mac, on Linux you can do that as well. Some Android devices don't allow you to update. So the problem with that is that you don't get any security updates. Meaning all your data, your private and confidential data, that is then can be accessed more easily by an attacker. So an operating system has to be confidential. You want to ensure that your data remains private. It has to have integrity, so your files shouldn't be messed with or when transferred on a network or other things. And of course you want it to be available anytime you want to use it. In the past there was systems that didn't have complete availability, so I'm talking like 50 years ago, and those were called mainframes, and then you could rent time on the mainframe. So of course with an operating system you want it to be available at any time you want to use it. So those are the main important things with an operating system in terms of security. Another threat in computing is malicious programs. So a malicious program might give access to the computer, or it might delete files, or can be all kind of things. So there's different types of malicious programs. For example, Trojan horse will give remote access into a computer. So that's one type of a malicious program. There is like the typical viruses that mess with your computer itself, or you could have other kind of malicious program that tries to steal your banking information and so on. So there's all kind of subcategories in malicious software, but usually software gets onto the computer by the user's mistake. For example, they might go to some link on the internet and just download the program and run it themselves. It might be disguised, so it might disguise as some kind of installer and they just click it and install it. It can be through email, so maybe they get an email and they run the program. So in this case there's some malicious program on the computer that they downloaded and they might run it, and that could give the user or the attacker access into the computer or whatever they want to do. Now this works for any system, so regardless of whether you use Windows or Linux or Mac or something else, Android, if there is a malicious program, that could give access into your complete system. So malicious programs is a very serious threat. So in this case there's Windows, but let me demonstrate just for example on the Linux computer. So for example, let's say the Linux user will start a malicious program. Now the attacker is of course listening for the user for a connection, and the user will start a terminal and then start the malicious program, right? So just in the terminal start shell script, which is what Linux users often do. So they start their malicious program, and you'll see something changed on the attacker's computer. We're now inside the Linux computer. So we can say, who am I? It's the Ubuntu computer. Put some configuration file, so you'll see we now have access into the computer. So this is called a reverse shell. It's a type of malicious program that allows you to remotely control the computer. So similar to our Trojan, we can remotely control the computer. For example, we can list the files in the directory and we'll see There's malicious.sh, which was just started, but also like we can browse their downloads folder, documents, desktop. And we can enter any directory. For example, we enter the desktop. Now let me minimize this. And let's say we create a file. So you'll see we have remote control access now using a reverse shell, using a malicious program. And this principle works for any system, regardless of whether it's a Linux computer, Windows computer, a Mac computer, Android. If there is a malicious program, they might access all your files. So of course the malicious program needs to be run. On Linux computers, this program is always run using // which whatever program.sh, and most Linux users will use shell scripts like this, so .sh files. Windows computers, obviously they use .exe files. So malicious software can run on any system. Now on the left we have a Windows computer, and if I start this malicious program here on the desktop, it will give us shell access or remote access into the computer. So if I double click it, you'll see something is changing here on the attacker's computer, and now the attacker can browse around the computer. For example, the ls command shows the current desktop with everything on the desktop. You might browse around using the command line. For example, into the documents directory or whichever directories there are here. For example, the work directory. Basically, they have control the computer now just because you started a malicious program. And you'll see they can do all kind of things with this shell. So you'll see can dump words. They might play audio commands. Might do something with the webcam, with the user interface. Some general things like restart the computer, stop programs, some network stuff, some commands we did before like change directory and download, upload file. Basically they have complete control now over the computer. So this malicious program on Windows, just one program, gave the attacker complete access into the computer. So it's running random software from the internet is a very bad idea because it allows your computer to be hacked without needing any password at all. So this type of malicious program is called a reverse shell. I have a course on reverse shells if you want to get into the details. You can create your own malicious programs that you can use to take over computers, which then you can control using the terminal. For example, we might type the reboot command and that would restart the computer. So you'll see now it's restarting the computer, but we did that from the attacker's computer. So all kind of commands, command line interface that allows you to remotely control the computer. So there are many different operating systems that you can choose from, regardless of whether you use a workstation PC or a mobile phone. The different versions of operating systems as well, which are essentially completely different systems. Let me start some here on this computer. So you'll see several systems running. Two different Linux systems, Kali Linux and Ubuntu Linux, as well as Windows 2000 here in the background. So there's many different computer systems you can run and you can choose from, and they all have different issues. So one of the main things you want to be sure of is the passwords. So as you see here, I started these computers and we didn't even require a password. So that would mean that anybody who has physical access to the computer can log into the computer, right? They just start and it doesn't require any password. Anybody would be able to go to, let's say, the documents and hey, there's a passwords file or whatever confidential data store inside the computer. Now you see that, let me close this one. You see that different applications can run on the system. For example, there's a web browser here, Internet Explorer. On Linux we have Firefox. There's a file browser. So all systems have a file browser, and basically applications run on top of the system, and applications can be the same. So for example, you can run Firefox on Windows, on Linux, on Mac, or you could run Chrome on any system. And so that is about the systems itself, right? So with both of these systems, we didn't need a password. So that is a serious problem for security. You want to set a password to secure of your data. So obviously the first thing when it comes to device security is the password. And you want password to be based on something you know, or something you are, or perhaps something you have. And so with most forms of authentication, the password is the most attacked one. Many people will use the same kind of simple passwords. You can find such password lists online. For example, the National Cybersecurity Center of the UK has published a list of the 100,000 most common passwords. So that is a list of the 100,000 most common passwords that you can find. Nice list. And hackers will use this kind of passwords list to automatically try to log into your computer. Now there's also another file like this that's called rockutxt. So the rockutxt is a similar list but containing 14 million passwords. You can download that as well. For example, here we have rockutxt that you can download. There's other password lists. So what hackers will do is one of the things they will do is to try and see if your system uses commonly used passwords. So in this case, there's a 100,000 commonly passwords, and you don't want to pick any password in that list, or any password in the list of rockutxt, the 14 million passwords. Now there's other password lists. So hackers will use these commonly used passwords to try and log in to your operating system. Now some are just basic sequences. So if we zoom in a bit on this list, you'll see that some people use 1, 2, 3, 4, 5, 6, or several times 1, 1, 2, 3, 4, 5, 6, 7, 8, and passwords like that. Now that is a problem because what I mentioned is that an attacker can either guess the passwords, but any professional attacker will just go through this list automatically with software and try to log into the system. So, for example, we have two computers here, and one is the Ubuntu Linux computer, and the other is the hacker's computer. And using weak passwords, the system can be easily compromised. For example, if we open a terminal on the hacker's computer, we can use a tool called Hydra to crack the target's password. So let me enlarge the font here. Make it more readable. So you see with the command ip-addr show, I get the IP address of this computer. Then I can scan what service it's running with a tool called nmap. So that tells you which applications are running. So in this case, it's running the application SSH. SSH allows you to remotely control a computer, similar to remote desktop in Windows. So now the attacker might use the tool called Hydra, which is a password cracking tool using the username. So in this case Ubuntu, it's a Ubuntu computer with a password list. So might use the password list we saw before, the NTSC list. So we'll use the NTSC password list to attack the computer. So if we scroll down here, it should be here somewhere. Okay, this is a small extract of the list. See the full 100K here. So we're gonna download that file and save it in the home directory. So home, save. And you see this list is the 100,000 most common passwords. So we'll use that. We use the list. Then the application was SSH. It was the result of nmap. That's an application publicly exposed to the network with the computer's IP address. So we're gonna paste that in. So now what it will do, the Hydra program, is to try for user Ubuntu every password in this list one by one to see if it is the correct password And this will just tell it try to log in over the SSH application on the target computer. This is its IP address. So if I press enter, you'll see it starts trying words, and you'll see it found the password. So because I didn't resize the terminal, it doesn't really fit well into the screen. So let me maximize it, run it again. Now the output will be a bit more readable. So you'll see it found the login and the password. So now we would be able to log into the victim's computer using SSH. If you want to learn a lot about SSH, I have a course on that. So we can log in to this target computer. And yes, we know the password because it was correct. It was one of the passwords in the UK's or the NCSC 100,000 common password list. So we can now type the password. And we are inside the computer. You'll see it says Ubuntu here. And if I resize this, you'll see this is a Ubuntu computer. And now we are inside the computer. So for example, I could go into the desktop directory, maybe make a directory. And in this case, it made that directory. So you see now we can remotely control the computer. And this was possible because they used a weak password. Right, you'll see can be added. And we can control the whole computer now using our attacker's computer. So all it took was one weak password. When we take a look at, so what you want to do is to pick a password that is more secure. So instead of maybe a password, try a passphrase. These passwords can be, it's just like commonly passwords. So you don't want to pick any passwords that is a common password. Because now I demonstrate hacking a Linux computer, but the same thing can be done with Windows or any other system. So you want to pick a secure password. So let's hack into a Windows computer. This Windows computer is running an FTP server. FTP allows you to share files over the network or the internet. So if you go to the internet, you can search for a program called xlite FTPD. And that's a small file sharing application you can use to share files on the internet. So you'll see there's a 32-bit and a 64-bit version, depending on your system. So we installed that. You'll see xlite FTP server running here. I pressed the plus, then we selected our IP address. You can type it in. If you don't know it, go to the command prompt and type ipconfig. It will tell you your computer's network address, also known as the IP address. And you'll see here 1.4.148. So I typed that in, I clicked OK. You'll see it already exists. Then select it, click the little user list icon, click plus, and add a user with a password and a directory you want to share. So just file sharing protocol. This is just one of the programs you can use for file sharing, right? So then you select it and click the green button to start the server. So why would you do all that? Well, then you can share your files over the internet and the network. For example, they can go directly from their file explorer and type p:// with the IP address of the computer, then username, password, and they can access the file. So that's an ID of a file server or FTP server. Now you can use FTP to share files over the network, but a hacker might try to gain access to that system. So in this scenario, both are on the same network, and on the left it's running the FTP server, and on the right we have a Kali Linux computer that will attack the Windows computer. Now in order to attack, it will use a password list. There's a default password list included in Kali in the directory user share word lists. So rocku.txt, I'm gonna copy that and click on the home directory. paste it in. Now extract it, right click, extract here. You'll see that extracted a text file. If you refresh it, you'll see rock.txt, which is a list of 14 million passwords. So I can show you the top of that list. Show you the first 100. So these are the 100 most commonly used passwords. And this file rock.txt, it contains 14 million commonly used passwords. So next we'll scan the target computer. Let's say we don't know the target's IP address. We can use a command sudo arpscan -l. That will tell you the computers on the network. If you run that, you will find out what is the computer's IP address. In this case, it's 148. So you can type map with the target's computer address to see what is running. So we enlarge this and map with the target IP address, and you'll see it's running an FTP server. So what you might try is to connect to it, right? So you might try, okay, open the file browser and say FTP with the target. And you'll see you can connect as anonymous maybe. And nope, that doesn't work. So we need a username password to log in, to access the files. So when we did the scan here and map, we actually see that the computer is named Frank. So that might be the username. Alternatively, you can try with a user list, or maybe you know the name of the person you're targeting, so you can use that name. So we type Hydra. Hydra is the tool we'll use for automated password trying. Of course, you can do it manually. So you could say FTP O, connect to the computer, username Frank, and then we could go through that list. So through that password list, open a new window here and show you the top 100 or the top 10 passwords. So you might try one by one the passwords, right? So let's say going to for password. Okay, that's not the password. So then you might try again. Of course, the username and the password. So then you might try the next passwords, right? So you might go for this password and then go through the list one by one until you find the password. So you see login failed. So obviously when you do it that way, one by one, going through every password, it's gonna take ages. So what you can do instead is use a tool that does that automatically. And that tool is called Hydra. So you type Hydra -l with the username, -P with the password list. Now remember, we copied the password list into our home directory, rock.txt. So we type rock.txt. Then we want to try to brute force FTP protocol, FTP:// with the target IP address. So we type that and we press enter. And that will try and crack the passwords. So in this case, it found the password. So it shows the target's computer address, the login name, and the password. So now we should be able to log in, either using the graphical interface, using the file explorer. We could type :/ with the IP address. Now we know the username password. And now we're inside the Windows computer, right? We could also do it using the terminal. You see, we can access any file now in that computer. Might do it through the terminal as well. So connect, if you prefer, the terminal interface, username, password, and we're in. So now we can use the terminal to browse around. So we cracked the password using Hydra. And in this case, it was running an FTP server. That's why we could log in. So FTP:// with the target IP. And it tried every password in the password list for that user. Now keep in mind, this is a lowercase l, and this is a capital case L. If you use a capital L, you can also specify a list of users. So you could say Hydra -l users.txt, where users.txt contains a list of all the users you want to attempt. And for the password, you use capital P with your file, and so on. So Hydra is a tool you can use for cracking. And you'll see when I type Hydra, it supports many things besides FTP. So they might be sharing something else on the network, maybe a mail server, POP3, or maybe a database, maybe TeamSpeak, or remote desktop, or anything else, right? So with Hydra, we can try to brute force any username password. That's why you want to pick secure passwords for your computers and for your services. Let's hack into a Windows box. So what we'll do first is start a Windows computer, in this case XP, and we'll start the hacker's computer, Kali Linux. And in this scenario, both are in the same network, in the same computer network, so they might be using a public Wi-Fi or something along those lines. So here we'll start Kali Linux. Kali Linux is the system we use for hacking. On the left we have the Windows computer, Windows XP, and on the right Kali is starting. Now, it might take a moment for it to start. So in this case it's starting in full screen. Let me resize that just to have both side by side. So you'll see it's still starting. Now the hacker may not want that anybody recognizes that he's hacking. So what he can do is start a terminal and type Kali-undercover. That will make the Kali system look like a Windows computer. So you'll see now it's running Kali undercover, and this takes a moment. So now it looks like a regular Windows computer. So just a little trick, it's Kali undercover. If we run it again, it will switch back to the normal Kali interface. So you'll see now it's switching back to the original, the normal Kali interface. If the hacker doesn't want to be caught, so if he's hacking in the public, they might try Kali undercover team. So Kali undercover. And that makes it look like a regular Windows computer, right? Or more or less, because of course here you will have all your hacking programs. So that's a hacker might do that. Next, it will scan what computers are on the network. So let me enlarge the font a bit here. So instead of 10, I'll make it a bit larger to make it readable. Might scan for what computers are on the same network as I am. So can do that with command sudo arp-scan -l. That will scan for the networks, for the devices. So that can be computers, but also printers or mobile devices and so on. So sudo arp-scan -l. You'll see that returns several IP addresses. So run that again just for the formatting. You'll see several IP addresses here. Every IP address is a device address on the network, and they have dots in between and 4 numbers. So that's an IP address or a computer address. So next, might be interested in what files is the victim sharing, right? So many Windows users, they will share files on the network for other people to access. So let me just log into the Windows computer. Let's say the victim is actually using the computer. They can go to their computer or any directory. For example, their home directory in the Windows computer. Sorry, document settings. They might have some directory here. Let's say work, and the work folder they share on the network, right? So right click, properties, sharing that on the network, and allow networks to change. Now obviously they want their firewall to allow it and not to block it. So in this case I just turned off the firewall, because many Windows users will do that. They feel annoyed by the firewall, so they'll just turn it off, right? So they share the network, the folder on the network. So let's right click, properties, sharing, and then make sure to select them, share folder on network, and allow network users to change my files. And there they might have some work files. So let's create some files. Let's say secret.txt, Okay, save it. Save. And create maybe some other files, like maybe an image or something like that. WordPad, let's say schedule, whatever. So they have different files that they're sharing on the network, perhaps for their colleagues to access or something like that. Now, what we can do is we can scan the target computer. So the computer's IP address using a tool called Nmap. Nmap will tell you which applications or services are running on the computer. So we press enter and you'll see it's running several stuff here, several applications with, you see it's Microsoft here, it's a Windows computer. One of the things they are running is file sharing, and you'll recognize that when you see stuff like NetBIOS and Microsoft-DS, then you know that, okay, they are sharing something on the network. So we can try with look what they're sharing, NMB lookup -a with the IP address. And you'll see what they're actually sharing. Now, what we can do is use an SMB client, -l, so the location. We paste this in. Then we need two backslashes in front. And then -i with the IP address so that it knows which IP it is. So we're going to press enter and asks for a password, but let's say we just press enter, see if that works, and yeah, it does. So we run this command and we find the shared folders. So in this case, we know, for example, it's sharing the work folder as well as the files folder, the C folder, and so on. So what we might do is now try to connect to any of those folders with the SMB client. So SMB client, now with the other slashes, then the name of the, sorry, not that, but the same name here that we got from the lookup -a. So the top one, copy, and I'm gonna paste that in, and then we want to look in the work directory, so /work, and the IP address that we were using. Now I'm gonna press enter again, and okay, now we have a shell. Let's see if we can list files. Yes, and you'll see here we have the files that was actually shared on the network. So we might get the secret.txt or the other file. We can download or upload thing using the get and put commands, and it now is downloaded into the home directory. So if we minimize this, go to our home directory, now we actually have secret.txt, so we can open it, and there we go, we got the file of that shared folder. So whenever you share folders on the network in Windows, keep in mind that other computers might be able to access it. In this case, we access it from Linux, and we were able to download files from that shared folder, and we can also upload them using the put command. So if we create some file, let's say some file, we can also upload that now into the computer. So we say put file.txt, and now if we were to look in the work directory, you'll see that now file.txt has been modified. So you can upload files, download files, or even replace files. So keep in mind that when you share files on your network, somebody else might try to gain access and modify, download, or upload files.